Okay, today we're going to go ahead and go over the beginning part of our stoichiometry unit, which is essentially just the math behind chemical equations. Okay, so when we're doing these problems here, the first thing we want to check is that we have a balanced equation. So let's look at this first problem here. In this first problem, we have two nitrogen, we have 6 hydrogen, right? Because 2 times 3 will give us 6. So this equation is balanced, so that's the first step you want to go ahead and take. All right, so let's kind of go over what is this equation here telling me, right? Because these numbers, we've kind of briefly gone over it, but these numbers indicate the moles that are needed in a chemical reaction. In other words, what this equation is telling me is that it takes 3 moles of H2 to make 2 moles of NH3. So it's kind of like a formula, almost like a recipe, okay? And it tells me that it takes 1 mole, there's an invisible 1 here, it takes 1 mole of N2 to produce 2 moles of NH3, okay? And you could also, it also kind of tells us how much we need of each one, right? We need 1 mole of this and 3 moles of this in order for the reaction, for this reaction to occur. So these occur in what we call ratios, mole ratio. So we're going to be using that, okay? So let's go ahead and work through some practice problems, and I think hopefully it'll make a little bit more sense after that. So let's look at this problem. It's asking how many moles of NH3 would be produced from 2 moles of N2, okay? In other words, if we had, rather than 1 mole, if we had 2 moles of this, how many moles of NH3 would be produced? That's what we're trying to figure out, right? We should have an obvious answer. If 1 mole equals 2, then 2 moles should equal 4, right? Because it's double. We're starting with double the amount. So that's the answer, but we're going to go ahead and go over how to do the conversions using conversion fractions, which we've been using, okay? So in this equation, I'm converting from moles of N2 to moles of NH3, okay? We can put this here. So I'm going from moles of N2, and I'm converting into moles of NH3. Okay? So where do I get my equivalent from? How many moles of N2 equal how many moles of NH3, right? Because we always have to have that equivalent. What equals what? But we just get that from our equation. My equation tells me that 1 mole of this equals 2 moles of that. So 1 mole of N2 equals 2 moles of NH3. Okay, so that's the conversion equivalent that we're going to be using. So similar to how I do my other problems, I start by simply listing what I'm given. So I'm given 2 moles of N2, so I'm going to list that here. So 2 moles of N2, right, times, so I'm going to go ahead and multiply here, a fraction, so times, and I'm just going to take that fraction that I had here, which was 1 mole of N2 equals 2 moles of NH3. I'm going to use that fraction to go ahead and put that in there, right? So if I start with moles of N2, then I know moles of N2 should go here. So I'm going to take this here and put that right there, right? So 1 mole of N2 equals, I want NH3, so I'm going to put this on top, equals 2 moles of NH3. So similar units there across, cancel. 2 times 2 gives me 4. So my answer is 4 moles of NH3, which is the original answer we had said, right? But I'm trying to give you a systematic way to be able to do all problems. Okay, so that's the process really. So let's go through one a little bit quicker, and kind of use the same thing, right? So next one, we're using the same equation. It says how many moles of NH3 would be produced from 6.5 moles of N2. So same problem, different number. All right, so if I have 6.5 moles of N2, which is my starting product, right? Okay, times fraction. Well, I know I want to have moles in the bottom of N2, so I put that in the bottom. Moles of N2 in the bottom. I want to figure out how many moles of NH3 I make, so I put that on top. Moles of NH3. And the equation gives me these numbers. So the equation tells me that for every one of these, I get two of these. So for every one of these, I get two of these. So my answer is simply 6.5 times 2. 6.5 times 2 gives me 13. Okay, so my answer would be 13. Don't forget your units crossing out. 13 moles of NH3. Okay. All right, let's continue here. So my next question here is, how many moles of H2 are needed to make 30 moles of NH3? Okay, slightly different. Now we're kind of working backwards, right? We know how much of this we want, but we want to figure out how much of this must have been used in the equation. So I'm starting with this, but I'm going to go backwards. But it's the same process, really. So let's go ahead and start, right? We start by always rewriting what I'm given. So I'm given 30 moles of NH3 times a conversion fraction. Okay, I take my units here, right? This is what I want to cancel, so I put that in the bottom. Then the next question is, well, what do I put on top? Well, what are we looking for? Well, in this question is how many moles of H2? So we're looking for moles of H2. That's what we're trying to convert to. Moles of H2. Okay, so we've got our unit set up. Now let's go ahead and find these numbers. So the next question is, well, what goes here and what goes there, right? Well, you use the equation to get these numbers. We know that for every 2 moles of this, you need 3 moles of H2. So really, we're just taking the number and we're putting it here. So right next to NH3, we have the number 2, so I put it here. So for every 2 moles of NH3, we need 3 moles of H2. Okay, so that's going to give us our problem here. So our answer is going to be 30 times 3, which is 90, divided by our bottom number, which is 2. So 90 divided by 2 gives us 45. Okay, our units are the only thing that's left over, which are moles of H2. Moles of H2. Okay, so that's really the main thing. Is where the main confusion might come from is, where do I get these numbers from? Okay, we get these from our balanced chemical equation. All right, let's go ahead and do 2 more problems, but now we are using a different equation here. So same process, just a different equation. So this problem, we have iron oxide reacts with 3 moles of CO, which is carbon monoxide, to make iron and 3 CO2s. Okay, 2 irons and 3 CO2s. All right, so let's go ahead and look at our first question here. Our first question is asking, how many moles of iron, right? So that's what I'm looking for. How many moles of iron would 30 moles of CO produce? In other words, 30 moles of carbon monoxide. Okay, so this is what I'm given, 30 moles of CO. Okay, so I'm going to go ahead and write that here because that's my starting product, right? 30 moles of CO. Okay, if it helps, you can try to first put the equivalents on the side here and then put them in, or you can just start putting units in automatically. Let's go and do the first method, which we put them on the side and then we go from there. Okay, so I know I want to go from moles of CO, so moles of CO, and I want to convert that into moles of iron, right? So moles of iron. My equation tells me that for every 3 moles of CO, I create 2 moles of iron. Okay, so I just wrote this on the side, but you can just put it straight in to begin with if you want. But I'm just kind of showing you guys where I'm getting these numbers from. Okay, so now since I start with moles of CO, I put moles of CO in the bottom. 3 moles of CO. So I took this whole thing, put it in the bottom. Now I want iron, so I'm going to put this whole thing on top. So 2 moles of iron go on top. Equals, so I have 30 times 2 is going to give me 60 divided by my bottom number, which is 3, right? So 60 divided by 3 will give me 20. 20. My units that are left over are moles of Fe. That is my final answer. Okay? So if this helps, list these steps. If you feel like you can just do it by listing the units, then just list the units. Okay? Okay, let's go ahead and go through one more problem here, and we'll go ahead and finish up. So last problem here, it's asking how much iron oxide, right? We're trying to figure out how much of iron oxide is needed to make 35 moles of CO2. Is needed to make, and this is what we're given, okay? So you can go either way. You can find how much is needed or how much you have to start with. It's really the same process. So let's go ahead to step 1. What you're given, rewrite it here so we can do a conversion. So in this problem, I won't list this information. I'll just do it within the problem. 35 moles of CO2. Okay? All right. So again, what I'm trying to figure out is I'm trying to figure out how much of this must be present in order to produce 35 moles of CO2. And I use these kind of equivalents to help figure that out. Okay? So I know I have moles of CO2, so I put that in the bottom. Moles of CO2. Okay, so if you don't know what you're doing, then that's the easiest way. Whatever we start with, put it in the bottom. Whatever we want, goes on the top. But we want moles of H2O3. It says how much. Should be more specific and ask how many moles. But that's essentially what we're doing today. Okay, so 35 moles of CO2. So we put moles of CO2 in the bottom. We want moles of FeO2 or O3, sorry, on the top. So iron oxide. So we put moles of iron 2O3 here. Okay. All right. Then where do we get my numbers from? The equation, right? The equation tells me I produce 3 CO2s for every 1. There's an invisible 1 here for every 1 iron oxide that reacts. So I produce 3, right? I put the 3 there. I produce 3 for every 1 of these. Go ahead and do my math. 35 times 1 divided by 3. That's 35 times 1 is 35 divided by 3. You don't have to do these problems in your head. So 35 divided by 3 would give me 11.66. I'm going to go ahead and round to that first decimal. 11.7. 11.7. Cancel. Cancel. My units are moles of iron oxide. Don't forget your units, and don't forget to box your answer so I know which one it is. Okay? Moles of iron oxide. And that would be our final answer there.